Good day to all. Today, we are going to talk about the laboratory experiment number 6, parallel connected resistance. By the end of this video, it will verify the principle that governs the resistance which are connected in parallel. In this experiment, we will be using PhET Simulator Circuit Construction Kit DC. Please stay tuned.
The members were given individual tasks that were accomplished in this experiment. Each member were required to film themselves doing each of their roles. First, Mark Daniel Majarucon filmed the introduction stating the title of this experiment, followed by the objectives and the material used. F.G. Charles Cordero conducted the experiment using the PhET Simulator Circuit Construction Kit DC, which was utilized from the previous experiment regarding Ohm's law. He also recorded and inputted the data on the table. Me, Nicole Belandres, wrote the procedure. Then, Shelley Grace Magno created a discussion alongside the observation made by Kian Manate and the analysis of Angela Teresa Sanchez. Lastly, the conclusion and editing was done by Emerine J. Larios.
So, good day, ma'am. So, this is our experiment using the PhET simulator. So, this is our first trial, this is our second trial, and this is our third trial. Then, this is our table with those values, and this is our computation in solving the total resistance.
And now for the discussion. In a parallel resistor network, the circuit current can take more than one path as there are multiple paths for the current. Then, parallel circuits are classed as current dividers. Since there are multiple paths for the supply current to flow through, the current may not be the same through all the branches in the parallel network. However, the voltage drop across all the resistors in a parallel resistive network is the same. Then, resistors in parallel have a common voltage across them, and this is true for all parallel connected elements. So, we can define a parallel resistive circuit as one where the resistors are connected to the same 2 points or nodes and is identified by the fact that it has more than one current path connected to a common voltage source. So, to summarize, when two or more resistors are connected so that both of their terminals are respectively connected to each terminal of the other resistor or resistors, they are said to be connected together in parallel. The voltage across each resistor within a parallel combination is exactly the same, but the currents flowing through them are not the same, as this is determined by the resistance value and Ohm's law. Then, parallel circuits are current dividers. The equivalent or total resistance of a parallel combination is found through reciprocal addition, and the total resistance value will always be less than the smallest individual resistor in the combination. Parallel resistor networks can be interchanged within the same combination without changing the total resistance or total circuit current. Resistors connected together in a parallel circuit will continue to operate even though one resistor may be open circuited.
We observe that the addition of more resistors causes the indicator bulb to get brighter. As the number of resistors increases, the overall current is also increased. This increase in current is consistent with a decrease in overall resistance. We observe if a bulb or an individual bulb in a parallel branch is unscrewed from its socket, then there is still current in overall circuit and current in the other branches. When one bulb is removed from its socket, the other bulbs in the parallel branches remains lit.
The three trial set of data are the resistance, current, and voltage. The first table are the values of resistance. Their values ranges from lowest to highest or ascending order, both resistance 1 and 2 in 3 trials, thus also giving them an ascending order for their total resistances. As for the table for current, the values for current 1 and 2 seems to have a descending order for each trial, and for their total current, which is the result from the sum of both currents, is also in descending order. Lastly, the values of voltage are both equal to their total voltage. We can tell that when the resistance is higher, the current is lower, and when the resistance is lower, the current is higher, thus having an inversely proportional effect with one another, which the values for the voltage remain constant and equal with one another.
In summary, when two or more resistors are connected so that both of their terminals are respectively connected to each terminal of the other resistors, they are said to be connected together in parallel. From the video presentation to the table method, we have discussed stated observations and analyzed the main points of parallel connected resistances. Therefore, it can be verified that in parallel connected resistances, the voltage is always constant. Currents also add up to equal a total larger current. And the total resistance of a parallel combination is found through reciprocal addition, wherein the total resistance value is less than the smallest individual resistor in the combination.